decided to take the approach of giving a visual representation of a mixture of octane and hexane, which have two input streams, one each, and one output stream, which is the mixture of the two hydrocarbons. So here's a little visual representation of our code. As you can see, our fluid properties, we have hexane and octane with their properties, viscosity and density. And we have the tank flow parameters as well, each of their velocities and concentrations, both inlet and outlet concentrations. And then we have our differential equation, which we use to solve the problem. We have the mixture properties, that is at the outlets, the mixture property. Steady state analysis value. This is because the MATLAB uses a differential equation to solve the problem, and we need the analytical values at steady state to be able to solve. So if both of them have the same answer, then it means that our approach was correct. Moving on, after running the code, we got steady state values for hexane and octane with mass fraction 0.6097 and 0.3902 respectively, and a mixture density of 675.50 kg per meter cube.
Now we move to the graphs. Now both concentrations start low and increase with time, with the blue one being hexane and the red one being octane. The curves rise quickly at first and slow down at level of. This means that the tank is being fed continuously and the concentrations build up. That means eventually the inflow will be equal to the outflow, so concentration stops changing. Hexane reaches a higher concentration than octane due to inlet fraction or inlet rate. With the second graph, hexane starts around 0.6 and slowly increases. Octane starts around 0.4 and slightly increases or stabilizes, and both curves become flat at steady state. This tells us that the composition of the mixture has no absolute amount, the ratio stabilizes, and the mixture becomes compositionally constant over time. Now here, the density changes over some time, and it moves towards the theoretical density of 675 kilograms per meter cube. With this, as mixing occurs, density becomes a weighted average. In the last graph, you can see that there is a slight increase at the beginning, and then eventually it becomes steady. So the fluid becomes uniform, and then viscosity stabilizes at steady state. Now this indicates that there's a complete mixing behavior.
So someone will ask us, what does our code prove? Like, what does our project prove? It means that the system is dynamic at first. It means it changes with time. But after some time, it reaches steady state where there is no further change in any of the elements. So this is the end of our presentation. My name is Tobu Emmanuel, and I'm with
Dobe Morine.
And we are your future engineers. Thank you for watching.